and we're ready to go. Now let me check again before we go too far here, and make sure there's nobody still in the waiting room. It looks like somebody is. Yes, Jakiria is. I'm glad I checked because she sure didn't show up. Okay, Jakiria is here. All right. So we're up to 11 students. That's good to see. All right. Any questions on anything? Is there a question? Okay, I can hear someone's microphone on is the only reason I asked. All right, let me explain to you a little bit of what Dr. Pruitt was talking about in the phone conversation this morning, the one that set me back. Okay. Evidently next week they have this. Oh, here's Jakiria. I thought she was already in. I've got her in, but evidently she wasn't able to make it in. Yes. Good. Okay, I'll try to get it. Now, I teach until 7:45 this evening, so it'll be late before the recording gets out there, but it'll get out there sometime after 7:45 probably. Okay, great. Thanks for letting me know. Okay. All right. Here's what the conversation was about and why we're late getting started. Sorry about this. Why does it always happen? Why can't they call it 8 o'clock? You know, because we don't have start class until 8:30, but that's because most of them don't get on campus until after 8:30, so it's a pain. But anyway, here's what the deal is. Evidently, spring registration is slow. Okay, so they're doing some fairly, what I consider, drastic measures trying to get it up. I don't see how this is going to make much difference, but this is what they're doing. They're requiring all faculty to be on campus 4 days next week. Okay, and they're going to have a big push for registration. They're going to have it on both campuses. I don't know where they're having it on the Birmingham campus. But on the Bessemer campus, it's going to be, what he was telling me, either in Ethel Hall Auditorium or in one of the big rooms in the Jess Lanier building. I don't know if y'all are familiar with Bessemer or not, but if you are familiar with that, those are the two buildings that set off sort of to themselves. They're the newer buildings on campus. One's actually an old building, but they've renovated it recently. They're going to do something similar to that for Birmingham campus as well. I just don't know what spaces they will be in. So I can't be there. My health does not allow me to be there. So I've got to get my people to cover for me, which is a real big pain in the neck as well. And it doesn't sound safe to me. Maybe it will be. Hopefully nobody will be exposed, but it just does not sound safe. Okay, here's somebody trying to come in. I think it's Terrell. Let me mark him present. Okay. All right, Terrell. We're just going over some things that are happening next week that are a little bizarre, different, unusual. So far, I think spring term registration must be pretty low. And because of that, they are going to have a big push next week, having all faculty on campus next week. I can't be there because of my health, but they're requiring all faculty to be there. They will be teaching remotely, you know, just like they are at home, from home, but in their offices. But when they're not teaching for so many hours a week, they're going to be in some designated location registering students. So it's my boss called this morning right at 8:30. I mean, it was it was, probably 8:25, because that's when I usually start setting up for class. I was working on putting a lab together for this afternoon's class, and I did that last night, but didn't have time to type it. So I was typing that this morning. I was going to stop at 8:25 to get it set up for class. The phone rang right probably 8:24. I went, oh man. And he stayed on the phone. I was, look, I've got an 8:30 class. Look, I got to get off. The class is supposed to be starting now. Wait, it's 8:31. I've got to get off. So that was how it was. I just could not get him, to let me go. So I've got a meeting it's supposed to start at 12:30. My class goes until 12:45. So I've got a meeting then there's an afternoon meeting. So I don't know when I'm going to get my lab done finished, but that's a different issue. They're kind of panicking. So the deal is, if you can get registered for spring classes, do it. Do it remotely if you can. Okay, I don't see why we have to be on campus, because we can't register students anyway. The students have to register themselves, and this new system banner does not allow us to register students, and yet they're wanting us there so we can get exposed. No, I'm sorry, that's probably not it. Okay, so anyway, so please, if you can, register for spring term. Register this week, register remotely next week, get it done so you don't have to go to campus, and and maybe they'll send some of the people home and not expose a great number of people. So anyway, that's why we're late getting started today. Any questions, issues, concerns, problems? Okay, so let's get started where we're picking up. We're in chapter 2, polynomial and rational functions. Hopefully you can see the slide here, right? Okay, we're beginning today, if I could get the thing to advance, 2.3, which is polynomial and synthetic division. Okay, now I'm going, here comes, I think it's Ivan. I don't know why the system blocks his name, but I believe it's Ivan coming in. Okay, now I already had him marked because my page was off, so Ivan's here. I hope it was Ivan. Anyway, he's getting marked as present anyway. Okay. Here is where I'm going to begin this. Let me see if I'm going to go to a new slide. This PowerPoint freezes up just about every time. Here are our objectives. Use long division to divide polynomials, and here's Ladarius. Let me see if I can get him in before they block his name. Ladarius is here. Okay. Good deal. For those who've just come in, let me also say this. Please, if you haven't registered for spring term yet, please register as soon as you can. They're having a big push on campus next week. If you need to register in person, then go to one of the two campuses, Bessemer or Birmingham, and do that. If you can do it remotely, please do it remotely. It's a lot safer. It's a lot better. They should be pushing that rather than having everyone come to campus. So please register for spring term as soon as you can. This week if possible, and next week. You don't have to go to campus. Register. If you need advising, there's virtual advising out there. Now, there's one other thing I meant to announce, but all this other stuff came up and I almost forgot about it. It's sort of a good news, bad news situation. The bad news is tomorrow is a holiday. The campus is closed. School is not happening. So if you have a class tomorrow, unfortunately, it will not be meeting. Okay? But the good news is it doesn't affect us any, does it? Because we meet on Tuesday and Thursday. So you can rejoice with that. Okay, so let's get back to where we were. What what our objectives here in 2.3, use long division to divide polynomials by other polynomials. Use synthetic division to divide polynomials by binomials of the form x minus k. I'll talk about that later when we get closer. And we'll use the remainder theorem and factor theorem to identify other information that will come in very, very handy in the future. Okay, now here's where they're beginning, and again the PowerPoint won't advance. Okay, long division of polynomials. Now, they don't give me much room to work here, so I'm going to let's have a review of long division. I know y'all did it back when you were in elementary schools and sometime or another you did long division. Let's do a practice on that and make sure we got it. Here's what we're going to do is divide 12. I'm not exactly making up a number, but it's sort of coming out of the woods somewhere. If I could get my pen to show up, there it is. Let's divide 12 into, we're going to do it the old way, long division, 6, 1, 9, 1, 6, 4. Okay, is that a big enough number for you? Okay, divide 12 into that number. How do we do long division? Addition, subtraction, and multiplication, we always start at the right and work our way to the left. Okay, we always start at the units and work our way up. Division, we start at the left and work our way down. Okay, that's a difference. And that's one reason perhaps they put the 12 on the outside over here to the left. So we do 12 into the biggest number, the smallest number it'll go into. 12 won't go into 6, but at 12 will go into 61. Okay? How many times? Anyone know? 5 times. What do we do next? Not yet. It's multiply. 5 times 2 is 10. Carry a 1, and that would be 60. Okay? Now we subtract. And the 6's go out, but the 1 comes down. Then we bring down the next digit, 9. And a lot of the importance here in division is keeping up with your digits, keeping everything aligned. Okay, now we try again. 12 will go into 19. 1 time. Okay, then we multiply. 1 times 12 is 12. And again, we subtract. Okay, in fact, I don't know if you've ever thought of this. Multiplication is repeated addition. Division is repeated subtraction. I don't know if you've ever thought about it that way, but that's indeed what it is. Okay, so here we're going to subtract, and that leaves us a 7. Now, how do we know we divided enough? Well, because this remainder here is not the full remainder, is less than the divisor. That's what we did. Here it was a 1. That was less than 12. 7 is less than 12. Okay, so we've got that. Bring down the 1. Again, keeping your bookkeeping straight. How many times will 12 go into 71? It almost goes 6 times, but it doesn't. It only goes 5 times. Okay, now I'm going to go and put my comma in there. You don't have to, but I'm going to. Okay, 5 times 12 is 60 again. Okay, and then we subtract again. And this time you subtract and get 11. Well, it's almost 12, but not quite, so we know we have enough times. Bring down the 6. Okay, how many times will 12 go into 116? That looks like 9 times, did someone say? Okay, 9 times. So let's do 9. Okay, 9 times 12 is 108. So that worked. And when you do your subtraction again, that gives you an 8, which is less than 12. So you've done well. Okay, bring down the 4, And lo and behold, how many times will 12 go into 84? 7 times. 7 times 12 is 84. It goes exactly that many times. 12 will go into 619,164, 51,597 times, okay? That was a review of long division. Did that bring back all the fond memories of long division, right? Yes, I could tell you were enthused about it. Okay, so what you do, you divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down, until you get to the end. Now, if this had turned out being, say, an 85 here, and that's an 84, you'd have one remainder. And you're out of digits, so what you could do is write that plus 1 over 12. I don't know if you remember doing that for long division. If you had a remainder, you could put the remainder over the divisor, and then you have a fractional form. Hang on to that thought too, because we'll be doing that type of thing as well. So that's a review of long division of numbers. Now let's move into long division of polynomials. Okay? Suppose you're given the graph, as if you're going to be given the graph, okay, the graph of this function here. F of x is equal to 6x cubed minus 19x squared plus 16x minus 4. Now, before we do anything else with that, let's think about that graph, okay? The leading term, this is where I usually suggest you begin, is 6x cubed, okay? We first look at the exponent, that's odd, okay? That means the function is going to be going up in one direction, down in the other direction, because it's an odd function, okay? Leading term. Then we look at the sign of the leading coefficient. That's a positive. So that means when x is getting large, f of x is getting large. When x is getting very negative, Tyler is coming in. Okay, let me get Tyler here, and then we'll proceed from there. Tyler is here, I hope. Okay. Now, Tyler, I hope you can hear me now. The big announcement for today, and it's one reason we're a little late getting started today, I don't know if you realize that, but they are really making a huge push to try to get registration up for spring term. And so my suggestion to you is, if you haven't registered for spring term, do it as soon as possible. Do it today if you can. Do it tomorrow if you can. Do it Thursday, Friday if you can. Get it done. If you really need to and want to be on campus, they're going to have a big push on campus all next week. I think Monday through Thursday is what I understood. I'll find out more today at a meeting I'm going to virtually, okay? And it's, you know, please, it's far safer to do it virtual registration than do it in person, okay? And I don't know why they're having the instructors there, because we can't register anybody anyway. But that's what they're doing. They're having all instructors go to campus all 4 days next week, Monday through Thursday, and to help with registration. We can't register students. Students can only register students. This new banner system does not allow an instructor to register a student. So we're just there. I don't know. It sounds crazy to me, but they're doing it. So please, if you can, register before next week or next week. You can still do it remotely next week. Do it, okay? But get registered as soon as you can, so they can cut out some of this craziness of bringing people to campus for basically no reason whatsoever. But they're doing it just because they're panicking, I think. All right, now, what you've missed so far is a review of long division of numbers, because we're going to be doing long division of polynomials, okay? They say, suppose you're given the graph of this function. Now, when are they ever going to give you a graph? Well, maybe occasionally, but this is a graph. And what I was saying is, what do we expect from this graph? Look at the leading term. The exponent is 3. That means it's going opposite directions. Because the leading coefficient is positive, that means when x gets very large positively, f of x is going positive. When x gets very large negatively, f of x is going very large negatively. So it's going like this, down to the left, up to the right. Okay? That's exactly what we see in the graph here, going down to the left, up to the right. That's our end behavior. Okay? Now, it says here, notice that a 0 occurs at x equal 2. Now you have to trust their graph to tell you that's right. It looks like there's either one or two other zeros right over here between 0 and 1, but you can't tell what they are, okay? Or it is, okay? But it does look like it's crossing the graph there. What does that mean? That means x equal 2 is a root, if they've drawn it correctly. 2, 0 is an intercept, if they've drawn it correctly, okay? So, it says, notice that a 0 occurs at x equal 2. Because x equal 2 is a 0, you know that x minus 2 is a factor. Those are some of the things that are all related to each other. If x equal 2 is a 0, subtract 2 from both sides and you get x minus 2 is equal to 0. That means x minus 2 is a factor. Okay, just like if you found that was a factor, you know x equal 2, add 2 to both sides, then this would be x equal 2 would be the 0. Okay, this means that there exists a second degree polynomial, q of x, such that f of x is equal to that linear polynomial, first degree, times some second degree polynomial to give you a third degree polynomial. Now, I don't know if you realize that or not. You probably did, but this is, kind of crazy. Okay, so what are they going to do? They're going to, since you know that this f of x, this big old thing here, is equal to x minus 2 times some other polynomial. Okay, we're going to use long division, and we're going to do that in example 1. So that's where we're heading, and I think that's what we're going to get to next. So here is, if they would just advance the slide, example 1. Divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2. We're going to do it long division. Later we'll do it in a shorter manner. But here's what we do. Put the x minus 2 on the outside of the house. Okay, that's the divisor. Inside the house we'll put 6. Yes. 6x cubed, I think your microphone's on, okay, minus 19x squared plus 16x minus 4. Sorry, my line is not going very smoothly there. Okay, now, yes. Okay, all right, thanks. All right. Now here's a couple of things to pay attention to. Be sure that both the divisor, the x minus 2, and the dividend, the big one, okay, are in decreasing order of the power. This is order 1, this is order 0. 1, 0, that's fine. Over here, 3, 2, 1, 0. Decreasing order of the power. Not just decreasing order, but you haven't skipped a term. We had them all accounted for. 3, 2, 1, 0. 1, 0. Everything's accounted for. If they're not, you need to put a 0 factor in there, a 0 term in there to cover any missing terms. We'll talk about that later. Okay, so we're set up, ready to go. Your divisor on the outside, the dividend on the inside. Everything has enough terms in it, so let's start our division. Now, Again, we start from the left and work our way right. Start with the leftmost term here, x. X will go into the leftmost term here. How many times? Well, the coefficient of x is 1. You don't see anything, you know it's 1. 1 will go into 6 times. Now I'll tell you, in the book they like to shift it over 1. Okay? Oh, here's somebody coming in, but I can't see who it is. Diana. Okay. Let me get Diana present, and we will go from there. Okay. All right, good deal. Okay. Diana and anyone else who came in recently, let me say this again. There is a huge push on campus now for people to get registered for spring term. Evidently, registration is down. It sounds like they're beginning to panic. So they're forcing all the faculty members to go to campus all 4 days next week. Okay? They've been making them go 2 days a week, those who can. I can't because of my health. They're not going to force me to go next week either because of my health. But all the others will be there. They will be teaching remotely from campus, which makes no sense, but they're going to be doing it virtually, okay? But they will be in designated areas in the basically all day long, Monday through Thursday, to help students register. Well, guess what? In the new banner system, we can't help student registers. They have to register themselves. So, but people will be there. So here's my advice to you and to all of you. Register today. Register tomorrow. Register this week. Get it done so you don't have to go to campus, but it's far safer to do it remotely. If you need advising, there's the Virtual Advising Center. That's what it's there for. It worked real well, I thought, for fall, but then I don't know if they haven't made a push. I don't know what's happening there. But anyway, please, because the faculty member cannot register you. You have to register yourself. So, but if you do need face-to-face, almost, they're going to have plexiglass between you and stuff like that. But, you know, so you can see somebody, then you can go to campus next week and do so. But it's far safer, far healthier, far better to register remotely. Do the virtual advising. That's safe, very safe. Okay. So anyway, we've done so far review of long division of numbers. Now we're extending that to long division of polynomials. What we have is to divide this big old polynomial here by this little bitty polynomial here. So this is the divisor. X minus 2 is outside the house, and inside the house is 6x cubed minus 19x squared plus 16x minus 4. Okay, so we put that inside the house. And as I said, division starts from the left and works its way right. All the other operators, addition, subtraction, and multiplication, work their way from the right to the left. Division goes left to right. So let's start with the left, and the first term you see here in the divisor is x. How many times will that go into 6x cubed? Well, the coefficient here is 1. 1 will go into 6 times. I was just saying the book shifts this over to here for a reason, and it's okay. I like it better here because you can see that things are lining up. Okay, so you took care of the numerical part. 1 will go into 6 times. Then do the variable part. X will go into x cubed how many times? X squared times. Okay, now just like when we're doing long division of number, you divide first, then you multiply. Well, that's what we do now too. 6x squared times x is 6x cubed. Okay, that's exactly what we wanted it to be. But then you do the 6x squared times a minus 2. That would be a minus 12x squared. See why it's important to keep the numbers lined up, the terms lined up correctly. Now with long division of numbers, what we did was subtract next. Okay, Now, because here you're dealing with signed numbers, how do you subtract signed numbers? You change the second one and add. So let's make this a minus and this a plus, and then add. Well, these two add to 0. That's exactly what we wanted them to do. These two add to be 7x squared. Okay? And what do we do next? Bring down the next term, plus 16x. Okay? Now, start over again. Do your division. X will go into 7x squared. Well, let's do the number part first. 1 will go into 7 plus 7 times. And again, the book will shift this over 1. That's okay. And the x will go into x squared x times. Okay? Now, multiply. 7x times x is 7x squared, exactly what we wanted it to be. And 7x times a negative 2 would be a minus 14x. Okay? Now we subtract or change signs and add. So change that to a minus, that to a plus, and add them. These two go away, which we wanted them to go. And this gives us a have I written something down wrong? Yes, I did. Sorry about that. This is a minus 7x. So this becomes a minus 7 here. I knew those numbers were not looking right. Okay. Sorry about that. That's going to be a plus. Okay. That's, well, let's start over. Okay. I may still need to erase some, but let's start. Okay. This part was good. Then this part is where I made the mistake. Oh, that's the one I needed to change. I knew it was somewhere else. There we go. Okay. All right. So x will go into 6x cubed, 6x squared times. 6x squared times x is 6x cubed. 6x squared times minus 2 would be a minus 12x squared. Change signs and add, make that the minus, that the plus. Add them, this becomes a negative 7x squared. Okay? And x will go into negative 7x squared. Well, the 1 goes into negative 7 times. X goes into x squared x times. Multiply, minus 7x times x would be minus 7x squared, and minus 7x times a minus 2 would be a plus 14x. Okay, then we change signs and add. Okay, so this becomes a plus and this one becomes a minus. Now I've got the magic pen, so that's real easy for me to do. However you do it, if you don't need to change signs and add, you don't have to. If you can subtract sign numbers without doing it, perfectly fine to do so. I just found out it makes fewer errors if you change signs and add. Now we add. These two add to 0. These two add to 2x. Bring down the minus 4. Now we do x into 2x. Okay. The numerical part, x will go into 1 will go into 2 plus 2 times. Okay. And x will go into x 1 time. So you don't have an x here. So 2 times x is 2x. And 2 times a minus 2 is minus 4. And those, if you change signs and add, they add to 0. Which means that is an exact factor. Okay? X minus 2 will go into that big old polynomial there exactly 6x squared minus 7x plus 2 times. Now, that means that they were absolutely right x equal to was a solution, x minus 2 was a factor because it comes out with no remainder. Okay, 0 remainder. Okay, now what do we do with that? Well, if you go back to the graph, you can see your zeros are where this is equal, the y value is equal to 0. That's what they are. Well, this one we know went into it exactly. So with what we've got left, that quotient, we want to set that equal to 0. Okay, so let's do that. It says use the result to factor the polynomial completely. So let's see if we can do 6x squared minus 7x plus 2. Now there's a couple ways we can try to factor this. One is trial and error. Hopefully we can make several trials without making too many errors and come up with a solution. Or the other method is called the AC method. Or the third method is called the quadratic formula method. Which way do you want to do? Trial and error, AC method, or quadratic formula? Doesn't matter to me which one you want to do. Anybody? Trial and error. Okay, here's what we're going to try. I want you to tell me what possible factors you have for 6x squared. There's several of them. Give me one. This is the trial part. What's one possible factorization for 6x squared? Anybody? 3x times 2x. Is that what you meant? Yeah. Now, we look at the sign of the last term. It's positive, meaning these two signs have to be the same. We look at the sign of the middle term, it's negative. That means both of those need to be negative. Okay? Now the next question is, what are the possible factorizations of 2? Now there's only 2 of those. What would they be? One of those. Anybody? Okay. I'm going to make it 2 and 1. Okay? And here's why. If we had put the 2 here and the 1 there, then this would have had a factor of 2. And here comes Shay. I believe it is. Okay? And I think I mistakenly marked Shay here already. Let me see if I can find her. Yeah, I had marked her when my page was off. Okay, so let me make sure that I did get, oh, here's somebody else I think hiding in there. Who is this? Did anyone see who that was? You probably can't see it. Let me go back here. Okay, I already had Anaya, Brianna, Shay's iPhone I've got now, Diana I have, Ivan I have. I'm going to make this bigger. Okay, Diana, Ivan, Jemiah, Kanisha, Rosa, Tamia, Tommy, Tyler, Weston, Ladarius. I think I've got everybody here. It should be 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We've had up to 17 people here. We now only have 13, so hopefully I've got everybody marked. It's going to be hard to figure out who's not here since so many have left. Okay, so we got this far, and do you sort of understand my reasoning of putting the 2? I wish I could get my pen to show up. Okay, there it is. Okay, the 2 over here rather than here, because the 2 were here, that means this thing would have a factor of 2. Well, this doesn't have a factor of 2 because of that 7. So I know the 2 has to go here and the 1 there. Let's check it and make sure we did it right. 3x times 2x is 6x squared. That checks. 3x times minus 1 is minus 3x. Negative 2 times 2x would be minus 4x. Minus 3x minus 4x is minus 7x. That checks. And then negative 2 times negative 1 would be plus 2. And that checks. So all three of those check. We know we have it right. Well, what we were doing was setting that equal to 0. Just like that. Okay? Now, here we have two factors with a smiley face. Okay? And these two factors multiply to be 0. That means one of those two, or both of them, have to be 0. So either 3x minus 2 has to equal 0, or 2x minus 1 has to equal 0. Okay? Well, let's solve this one first. Add 2 to both sides. And what do we have? These two add to 0. 3x is equal to 2. Add 1 to both sides, and you get 2x is equal to 1. Well, divide here by 3. Divide here by 2. You can do this one at a time. You don't have to do it like this. These go to 1. These go to 1. This gives you x equal 2/3. And this gives you x equal 1/2. Guess what, team? Let's go back to your drawing, the graph that we had. And that sure does look like this one right here, if I could get the pen to show up, could be 1/2. And this one right here could be 2/3. So that makes sense with our drawing, with our graph, that those two could be two distinctly different zeros, really close to each other, but two different zeros. So that makes me feel really warm and fuzzy inside. Both of them are positive, just like we found. Everything's looking right. Okay? Was that our question? All right. So let me clear my drawings so you can read better for what we're going to do next. And here's how they do theirs. They put the x minus 2 on the outside. They put the 6x cubed minus 19x squared plus 16x minus 4 on the inside. Now, what they didn't say, make sure that both the divisor and the dividend are in decreasing order of your powers. 1, 0, 3, 2, 1, 0. And make sure you haven't skipped a term. 1, 0, you didn't skip anything there. 3 to 2, you didn't skip anything. 2 to 1, you didn't skip anything. 1 to 0, you didn't skip anything. Make sure that's true. If this had been an x to the 4th, 6x to the 4th, and then you would have to have a 0 term in here for x cubed, 0x cubed. You have to account for every term. Okay. Now, what they do first is x in the 6x cubed. Now, I told you the book likes to move it down here and put the x squareds over x squared, which is perfectly fine. It's perfectly good. I like it here because you can see the division better, but that's my preference. So x will go in the 6x cubed, 6x squared times, and that's what they're showing here. 6x cubed divided by x would be 6x squared. Okay? Then the next thing you do is multiply. 6x squared times x is 6x cubed. 6x squared times a minus 2 is minus 12x squared. Then you subtract. Okay? This will subtract and go to 0. This will subtract, and here's where I like to change signs and add, because a lot of times students will make errors here subtracting sign numbers. So if you change signs and add, this becomes minus, that becomes plus. In fact, I'm going to write it in. That becomes minus, that becomes plus. And when you add, that obviously is going to 0, and this is obviously going to negative 7x squared. Okay? Then bring down the next term. Okay? Plus 16x. Now we do our division again. the minus 7x squared divided by x. That's what they say up here. Okay. I like to think 1 will go into minus 7 times. X will go into x squared x times. I like to think of it that way. They say this way. Both of them are correct. And when you multiply that, you get minus 7x times x is minus 7x squared, and minus 7x times a minus 2 is plus 14x. That's where I didn't bring up my minus sign before. And here's somebody, I think it's Terrell coming back in. I can't tell for sure. Yeah, I think it was. So that's already got him marked present. Let me make sure everything lined up properly. Yeah. Okay. Now, then we do x will go into minus 7x squared, minus 7x times. Okay, that's what they said there. I like to do 1 will go into minus 7 times x will go to x squared x times. Then multiply. Minus 7x times x is minus 7x squared. Minus 7x times minus 2 is plus 14x. Then I like to think of this as changing signs and adding. Okay, so this becomes a minus here, and when you add those go away, which is exactly what we want to happen, and this leaves us a plus 2x. Now that's a pretty obvious subtraction here. 16x minus 14x is 2x. So that one was easy to do that way. Then we do divide again. 1 will go into 2 times. X will go into x 1 time, so you just have a 2 here. Then you multiply. 2 times x is 2x, and 2 times a minus 2 is minus 4. You wind up with a 0 remainder. Okay. Now, notice here, every time we did our subtraction here, you wanted to make sure that what you left here, that if the degree of your divisor was greater than the degree of your quotient, of your remainder, keep dividing, keep dividing, keep dividing. Once you get the degree of the remainder is less than the degree of the divisor, stop, you're through. Okay, so this had the same degree, x and 2x, both are degree 1, keep dividing. Okay, your remainder has to be less than the degree of the remainder has to be less than the degree of the divisor, which is sort of like it was when we were doing our division of numbers. Okay, so there's our quotient with a 0 remainder. There's your divisor. That was your dividend. Okay, remember those old terms? Still use them. From that division, you can conclude that this big old polynomial here can be factored into x minus 2. And here comes somebody. I think this is Shamari. Can't remember if Shamari was here already. No, she wasn't. So let me mark Shamari is here. Okay. Winding up to be a pretty good sized class today. Okay. So this factored into x minus 2 because you had a 0 remainder into exactly 6x squared minus 7x plus 2. Let's see if we can factor that. And we did it by trial and error and got the same thing they did, 2x minus 1 times 3x minus 2. We put them in different order, but that doesn't matter. Okay, so now we have factored that cubic function completely into 3 linear factors. Okay, so we've done it as far as we can. Then we can set that equals 0 and find x equal 2, x equal 1/2, and x equal 2/3. That's exactly what we were looking for. Okay, I can't get this to advance. PowerPoint's such a pain in the neck. Okay, in example 1, x minus 2 is a factor of the polynomial, and the long division process produced a remainder of 0. That has to be, if x minus 2 is a factor, it's got to have a remainder of 0. Often long division will produce a non-zero remainder. And when it does, you know that your divisor is not a factor of that dividend, okay? But it still gives you good information, okay? For instance, when you divide x squared plus 3x plus 5 by x plus 1, you'll get the following. Put the x plus 1 outside the house, the x squared plus 3x plus 5 inside the house. Make sure you're in decreasing order of your powers, 1, 0, 2, 1, 0, and that you haven't skipped any powers. We didn't, okay? So x will go into x squared, x times. Again, 1 will go into 1 time, x will go into x squared x times. I like to put this above, they like to shift it over 1. Doesn't matter. Okay, multiply, you get x times x is x squared, x times 1 is x. Now I like to change signs and add, but this subtracts pretty nicely too. X squared minus x squared goes to 0 if I could get my pen oriented properly. And if I could find where the pen is on the, there it is. So that subtracts to 0, this subtracts to 2x, okay? And 2x is the same degree here, so we divide again. I'll bring down the 5, divide, x will go into 2x 2 times. 1 will go into 2 twice, and x will go into x 1 time. So that's your quotient part. Multiply, 2 times x is 2x, and 2 times 1 is 2. Now when you subtract, these go away just like before, but this gives you a 3. So this time we have a remainder. Another way to write that remainder is like this. That would be plus 3 over the divisor, x plus 1. So this would be the polynomial part, and that will be your rational part. Okay, we will be doing that a little bit later. I'm surprised they didn't do it now. Okay, but that's another way to write that quotient, is a polynomial quotient with a rational part. Okay, and here's where they did it. In fractional form, you can write that result as the dividend divided by the divisor is equal to the quotient plus the remainder over the divisor. That's exactly what I did before. That implies, okay, what if you multiplied everything by your divisor? So here, this would go out. Trying to find my pen now. Where are you, pen? Oh, there it is. Okay. So if you multiply this, it goes away. Multiply here, that would be x plus 1. And you multiply here, and it goes away. And that gives you your dividend. So you've lost all your quotients here. The dividend is equal to the product of the quotient times the the divisor times the quotient, and then you have remainder left over. Okay, that's what you get from multiplying everything on both sides by x plus 1, your divisor. That illustrates the following theorem called the division algorithm. Now, it's just what we've just done. They've just given a big name to it. If f of x, now that's what they call the dividend, the big function you start with, and d of x, that is the divisor. That's what the d stands for, but dividend also starts with d. So this is divisor. If both of these are polynomial such that this divisor is not equal to 0. Now, of course, why can it not be equal to 0? You can't divide by 0. Okay, so don't do it. Okay, this, as long as that divisor is not equal to 0, and the degree of d is less than or equal to the degree of f. Remember, this has to be your divisor has to be lesser degree than your dividend. It can't even be equal. Okay, so if that's I'm sorry, it can be equal you still divide. It can't be greater than, okay, the degree of f of x. And there exists a unique polynomials, q of x, which stands for quotient of x, and r of x, which stands for remainder of x. Now that remainder we just had was just a number. Didn't have an x in it, but that's okay. It's still a function of x. And this is true, then your dividend is equal to your divisor times your quotient plus your remainder. That's your division algorithm, okay? The other way to write it is, now, if that remainder is exactly 0, then the degree of r, or if the remainder is less than the degree of divisor, which it has to be, then the remainder, wait a minute. Okay, they've written this really poorly. Where r of x is either equal to 0 or its degree is less than the divisor, d of x, okay, the degree of that. If the remainder is 0, then d of x divides exactly into f of x, q of x times. It divides evenly into f of x. When the r of x is not equal to 0, then you are have what is, well, it's just like dividing other things. You'll have a fractional quotient, which is a rational expression rather than a polynomial. Okay. Now, division algorithm can also be written as, let's go back one. Okay. If you divided everything here by the divisor, you'd have f of x over d of x. These would go out is equal to q of x plus r of x over d of x if you divide it by d of x. And that's exactly this form. F of x divided by d of x is equal to q of x plus your remainder over your divisor. In the division algorithm, the rational expression f of x over d of x is improper because the degree of f has to be greater than or equal to the degree of d. It has to be, okay? But your remainder over your divisor has to be proper because it has to be less degree than the degree of the divisor. On the other hand, the rational expression r of x over d of x is proper, just like proper fractions. Remember, 1/3 is a proper fraction. 3/2 is not a proper fraction because the numerator was greater than the denominator. Or even 3/3 is not proper because it's the same. Well, here we're talking about degree, and it's improper if the degree is greater than or equal to the degree of the quotient of the divisor. It's proper if the degree of the r of x is less than the degree of the d of x. And that's one of the requirements. Okay. Now, before you apply the division algorithm, now here's what I was saying from the beginning. They're finally getting around to saying it. Write the dividend and the divisor in descending powers of the variable. 3, 2, 1, 0, blast off. 2, 1, whatever. Okay. Now, if you don't have every term accounted for, like if you're missing the squared term, you have to insert a placeholder with a 0 coefficient for the missing power of the variable. Why they waited till the end to tell you that, I don't know, but they did tell you. By the way, we did do example 1. I forgot to mention to you, it does have a checkpoint. Please do the checkpoints as soon as you can. All right, we've done the division algorithm. I think we're ready for example 2. Let's see if they do example 2. No, they don't. Okay, so we will do example 2. Okay. All right, I think we're set up for example 2. How are we set up on time? Goodness gracious, we only got 3 minutes. All right, so here we have divide x cubed minus 1 by x minus 1. and it says check your result. Okay, well, this is the dividend, that's the divisor. So you put the divisor outside the house, x minus 1. Notice your degree is 1, 0, not skipping any terms. But inside the house, we have a problem. The x cubed is fine. That goes first, but we're missing an x squared term, so we have to put plus 0x squared. That's what they mean by putting a 0 placeholder. But we're also missing an x term, so we have to put a 0x. Then we have our constant term minus 1. Okay, so we've accounted for every term. 3, 2, 1, 0, blast off. Okay, now we do our long division. X will go into x cubed, x squared terms. I like to write them here. The book likes them in the other place. X squared times x is x cubed, and x squared times minus 1 is minus x squared. You see why you have to have it? Because otherwise, if you'd had 1 up here, you can't subtract x squared from 1. Those are not like terms. So you have to have every term accounted for. Okay? Now we change signs and add. Make that minus, make this plus. That gives us a 0 here and an x squared here. Bring down nothing. Okay? 0x. Okay? X will go into x squared plus x times. X times x is x squared. X times minus 1 is minus x. Okay? Change signs and add, and this gives you an x. Bring down the minus 1, and look at that. X will go into x one time, and when you multiply, 1 times x is x, 1 times minus 1 is minus 1, so that gives you x minus 1. That meant it went into it exactly as an exact division. In other words, this is a factor, that's a factor of this. But we knew that, didn't we? How do you factor the difference of two perfect cubes? X cubed is a perfect cube, x is 1's a perfect cube. What you do is take the cube root of the first, x minus the cube root of the second, or whatever sign that is of there. That's your first term. And then you do what? Square the first term, x squared. Opposite the product of these two, well, the product would be a minus x, you make it a plus x, and then you square the last term, making it a plus 1, and sure enough, that's what you got as your quotient. So I didn't exactly check it, but we sort of did. Okay, to check it, all you do is it's sort of like a foiling, only you got too many terms. X times x squared is x cubed. X times x is plus x squared, and x times 1 is plus x. Now let's do the second one. Minus x squared minus x minus 1. Add them together, you get x cubed. These add to 0, these add to 0, minus 1. That's exactly what you had here, x cubed minus 1. Make sense? All right, sorry we ran out of time today. Most of that was because my boss called the very first thing, well, like 5 minutes before class was to start, and that's when I was going to be getting the class set up. I couldn't because he called and he stayed on the phone so long. I said, look, I've got to go to class. But anyway, we've done example 2. Right after example 2, there is a checkpoint. Please do the checkpoints, and we'll begin next time with example 3. Homework exercises here will include, we got pretty good progress today. Do number 7. It should be at Calc Chat. Do number 9. It should be at Calc Chat. Now it says you might need technology there. I don't think you will. I think you can do it Basically, they give you the answer, but you should be able to do it. And then do any of the odds 11 through 21, no, through 23. They're all at Calc Chat, 19's at Calc View. And stop there. We'll do synthetic division next time. Okay. And if you can't get, yes. Okay. Okay. Now I've got only 15 minutes between classes. Do you want me to just stay on and everybody else get off? Okay. So if everybody else will go on and get off, do you need the board here, or is it something I can answer without the board? Okay. Well, I'm going to stop this. Yes. Chapter 2, Section 2.3. Okay. Alrighty. Okay. So if everybody else will get off, Shay's got a question. Okay. Rosa, yep. Kanisha, Anaya, Jemiah, and Ivan. If you can get off so Shay can ask me your question. Hello, hello. Kanisha, Anaya, Jemiah, and Ivan. Can you please get off so Shay can ask me a question? Okay, it sounds like they're not even listening. Oh, let me also do this. Let me end the recording here.